Hey everyone, my name is Lucas Rivera, and my research project this semester was the design and fabrication of a rainfall simulator for soil erosion testing. Kind of an introduction of this is rainfall is a huge deal, especially in arid regions such as where we live in Las Cruces, and it causes a lot of erosion, which is a problem that we try to mitigate, especially because the runoff from stormwater events generally causes damage. It can create settlements within our piping systems, and it's just overall a problem that we work with. And the problem with testing our mitigation solutions to rainfall runoff is that if we wait for only rain events, we might be waiting a long time. We live in the desert. So my project was to design a rainfall simulator that properly mimics, that simulates rainfall events that we see that are characteristic to this region. So those were my objectives, was to design, fabricate, and test a mid-scale rainfall simulator, and then to make it available for use for anyone that wants to use it. The methods, so instead of reinventing the wheel, there's been a lot of research in rainfall simulators, so I took a good look at those. I designed and prepared them, as you can see in the picture of the design, and then the construction, testing, and optimization. So that's as far as I got this semester. Is I was able to construct it, test to see that it works, but let's see how well it works, and that's where the testing and optimization comes up. The design parameters of this is we want a rainfall simulator that has uniform raindrop sizes, and that are, when I say uniform raindrop sizes, meaning that they're within range of typical natural raindrop sizes that we see in nature. Capable of replicable test results, meaning that we're getting the same raindrop sizes, the same parameters every single time. User-friendly and accessible for use, so ideally anyone will be able to use this, and adaptable. This rainfall simulator won't just be limited to certain types of tests. It can run a wide range of them. So in the design of it, and let me see if I can zoom in a little bit, you can see this design was primarily made to be adaptable. We're using galvanized sign metal, meaning that it can slide up and down. We have bolt connections, all for adaptability. This actually changed in the course of design purely because we needed a bigger base, and some free metal. A lot of this design was also taken from various sources, such as the pressure regulator and this full jet 30SQ nozzle. These are kind of the name of the game when it comes to rainfall simulation nozzles, so that's what we used to purchase. And then we have the pressure regulator. That way we can optimize what pressure works best for producing the best type of rain flow. And in the design we've included a solenoid valve, but in the construction we didn't, which you will see here shortly as I show a demonstration of the current rainfall simulator prototype. Thank you. Alright, here we have the final constructed rainfall simulator. This is at its lowest height setting. As you can see, you can adjust the height by unscrewing these bolts and extending it, as well as up there. We're attached to a regular garden hose, but the pressure is regulated by that golden pressure regulator that feeds into a 4-foot long galvanized 1/2-inch pipe that then goes to a nozzle that simulates rainfall. In the future, I'd like to add a solenoid valve to control the flow at time intervals, but we'll see how this looks once I turn it on. And here we have the functioning rainfall simulator. In the future, I'd like to invest in a high-speed GoPro camera that's capable of getting wet and measuring the raindrop size, but just from feel, it feels very similar to natural rain. We'll do optimization tests to see which height will give us the best results, how well distributed the raindrops are, and we'll go from there. But here we have the functioning rainfall simulator. Thank you.